Let's take a look at two applications of fractions. In the first problem, Jai walks to school and takes the bus home. Jai lives 7/9 of a mile from school, and he walked to school 6 days this week. I wonder why he went to school 6 days. Oh well, we'll worry about that later. So each day he walked 7/9 of a mile, and he did that for 6 days. So what that means is we need to find out what the value of 6 copies of 7/9 is. Because basically he walked 7/9 of a mile and he did that 6 times. So we have 6 copies of 7/9. We could think of this as repeated addition, meaning we would add 6 copies of 7/9 together, and that would cover each day, the distance that he walked each day, and we would put it together and we would have 6 of them. Since we have a common denominator, we can just add the numerators. So we would add all 6 of those 7s together and place the result over 9. So if I add 7 plus 7 plus 7 plus 7 plus 7 plus 7, I get 42 over 9. Or we could recognize that the repeated addition is just multiplication. So if I have 6 copies of 7/9, that means I'm multiplying the number 6 by the fraction 7/9. So I rewrote 6 as 6 over 1. And then I rewrote the number 6 as a product of 2 factors, 2 times 3. So I rewrote the number 6 as 2 times 3, and then I'm rewriting the number 9 as 3 times 3, because I need to simplify this fraction. So I notice that the numerator 6 and the denominator 9 share a common factor of 3, and then I can multiply the factors that are left over. So in the numerator, 2 times 7 is 14, and in the denominator, 1 times 3 is 3. So that original fraction, 42 over 9, that simplifies to 14 over 3. So we can say he walked 14/3 miles, but in the context of the situation, to really understand how many miles that is, let's figure out how many whole miles that is and write it as a mixed number. So that means he completed 4 whole miles and then 2/3 of a mile left over. So he walked 4 2/3 of a mile. All right, let's look at the next problem. Dawn made 30 quarts of punch for a wedding party. Each glass holds 6/13 of a quart. So she has 30 quarts total, and each glass can hold 6/13 of a quart. I always recommend changing the fractions to whole numbers in your mind to help you understand how to set the problem up. And then once you know how to set it up, then you can replace the whole number with a fraction. So here's what I mean. Let's say instead of each glass holding 6/13 of a quart, let's say each glass held 2 quarts. Let's make it something simple. So if she had 30 quarts total and each glass held 2 quarts, that means we could get 15 glasses because we would just do 30 divided by 2. Well, now each glass holds 6/13 of a quart. So really, this is just a division problem. We're trying to figure out how many copies of 6/13 of a quart will fit into 30 quarts. So we're asking ourselves, how many copies of 6/13 are in 30? So that's a division problem. That's 30 divided by 6/13. So I wrote 30 over 1, and then I'm going to change I'm going to change division to multiplication and take the reciprocal of 6/13. So really, I just have 30 over 1 times 13 over 6. So I notice that the numerator 30 shares a common factor with the denominator 6. So I can divide out the common factor of 6, and then in the denominator, it just leaves behind a 1. So now to multiply my fractions, I multiply 5 times 13 in the numerator and 1 times 1 in the denominator, which gives me 65 over 1, or just 65. So that means she can serve 65 glasses of punch.